Hello everyone, welcome to the lecture Deep Learning. My name is Hamidur Rahman. I am a PhD student in Melardolan University. In this lecture, I want to discuss an example of real-life application where convolutional neural network or CNN has been used. In this lecture, I want to discuss this article, Improving Multi-View Face Detection with Multitask Deep Convolutional Neural Networks. This article was published in 2014 in IEEE Winter Conference of Application of Computer Vision. Let's see the outline of my lecture. At first, I want to discuss about the problem overview of this example, and then I will present about the materials and methods of the example. After that, I want to show the system overview briefly, and I will explain how CNN is used to solve this problem. And finally, I want to discuss about the result comparing other methods. So, face detection is one of the fundamental research in many real applications, such as human-computer interaction, national and private security, and so on. For frontal face detection, Viola and Jones algorithm are used extensively, and it's the seminal work in face detection research. But multi-view face detection is still a challenging task due to consider various pose and movement of the person, environmental illumination, etc. This paper introduces deep convolutional neural networks or DCNN as the post filter. Face images are divided into several categories such as frontal, half frontal, profile, etc. A multitask learning or MTL framework is used to learn the post filter, jointly train the facial or non-facial decision, the facial pose estimation, and the facial landmark localization problem simultaneously. Now I want to discuss about materials and methods. Images have been collected from web and from several databases such as Freight database, BioID database, Pi database, etc. Images are considered as frontal, left-right profile, left-right half profile, left-right plus minus 30-degree rotation. Here is the number of images for each cases. The number of frontal face images are 49,000, half profile face are 43,000, and profile face are 25,000. For the CNN, the used facial patch size or the region of interest is 32 by 32 pixels. The face detection has been conducted in two steps, where the first step, Viola and Jones method, has been used as a primary face detection, and then deep convolutional neural network or DCNN has been used for the final decision. This is the overall system overview. The author used multitask DCNN to build a post filter for a boosting based multi-view face detector. The overall flow for predicting whether a given region of interest or the image patch is a face or not is shown in this figure. The image patch first passes through a cascade based multi-view face detector. If the decision is true, they scale the patch to 32 by 32 pixels and perform pre-processing for the patch. It is then sent to a DCNN for the final decision. Since the first stage multi-view face detector is a cascade based, it is fast and it can reject most negative patches. Cascading is a particular case of ensemble learning based on the concatenation of several classifiers, using all information collected from the output from a given classifier as additional information for the next classifier in the cascade. Unlike voting or stacking ensembles, which are multi-expert systems, cascading is a multi-stage one. Consequently, the overall system can still run fast multi-view detector input paths reject despite the relatively more complex DCNN classifier. So, the image patches are pre-processed before sending to the DCNN for classification. To increase the data variation, some tasks are performed, such as lightening and geometry variations to the phase passes, flipping, shifting, scaling, rotating for the cropping region, shearing in horizontal and vertical directions, intensity variance, scaling, intensity gamma nonlinearity, etc. The pre-processing also consists of three steps, that are histogram equalization, linear lightening removal, and intensity normalization. Here are some sample of past processing before being sent to the DCNN. Here the top row before pre-processing and bottom row after pre-processing.